Welcome back. Today's video is on solving equations. I realize I gave you the 1.3 solving equations. After looking this over, I feel like it would be more beneficial for you if we kind of improvised and went through our own set of notes. So you could keep this paper, look over it if you want, just on the side or on a new sheet of paper. We're going to go over some properties, several equations, and also literal equations, again, that are not on here, that I'm just going to make up off the top of my head that I think that you may struggle with next time in class or on an assessment or on the state test. So let's get it done. Start with this first equation. The first step for solving this equation would be to distribute on both sides. Negative 3 times 2w is negative 6w. Negative 3 times negative 7 is a positive 21 equals 9. And here's a big mistake that I think you may make. This 2 is being distributed, but it's not a positive 2. It is a negative 2. Always look next to on the left of the number to check if it's positive or negative. So we're distributing the negative 2 here. Negative 2 times 5w is negative 10w. And then distribute the negative 2 to the 4, which is negative 8. Our next step is to combine like terms. There are no like terms on the left side to combine, but on the right side we have a 9 and a negative 8. Remember, look to the left of the number. That leaves us with 1, and we still have the negative 10w. The next step is to move variables to the left and constants to the right. I'm going to move my negative 10w to the other side by doing what's called the addition property of equality, meaning that I can add 10w to both sides. And I'm left with a 4w plus 21 equals positive 1, since those canceled out. Next, I need to move my constant by doing the subtraction property of equality, subtracting the 21 to both sides, canceling those out, leaving myself with 4w equals a negative 20. The last step is to do the division property of equality. I'm going to rewrite my equation up here. I'm going to divide both sides by the coefficient, canceling that out, making a 1. And then negative 20 divided by 4 through division is negative 5. Always box your answer. I can check my work once I'm completed the equation by substituting in negative 5 in for w. I know a lot of people don't like doing this because it's a lot of work and they're really lazy, but if you want a good grade and you want to make sure that you're accurate when solving the equation, you could substitute in your answer and make sure that the left side is the same as the right side. Let's do another one. Okay, let's write one down here. M minus 4 over 3 minus 3m minus 1 over 5 equals 1. A lot of fractions here. I know some of you are groaning over these fractions and how to start this problem. My first step would be to get rid of the fractions by finding the least common multiple of these two denominators of 3 and 5. Least common multiple is 15. What we're going to do is multiply every single term by 15. Multiplying this first term by 15, multiplying, the second term by 15, and on the other side as well. 1 times 15 is 15. Doing this will simplify this part. 15 divided by 3 is 5. And this part, 15 divided by 5 is 3. And now we got rid of the fractions and we can distribute and solve. Distributing here. Distributing a -3. Be careful there. -3 times -1 is a +3. Now we can combine like terms. 5m minus 9m is a -4m. -20 plus 3 is a -17 equals 15. Almost done. Addition property of equality here, adding the same number to both sides. We're left with -4m equals, those canceled, 32. Finally, division property of equality, dividing both sides by the coefficient. We're left with m equaling a -8. We can always check our work by plugging in, using substitution, -8 in for both m's to see if I get the same answer on both sides. Did end up getting a fraction as an answer. That's okay sometimes. In Algebra 2, we like fractions, we encourage fractions. Just make sure you check your work. But if you do get a fraction as an answer to an equation, that could happen. Fractions are okay. Let's move on to do some literal equations. The definition of a literal equation is basically an equation that has no numbers in it. Let's do a quick couple examples. Let's solve I equals PRT, but I want to solve it for P. I want to get P by itself. I'm going to rewrite my equation, but I'm going to leave P as its own color, just for myself to know that I'm trying to get P by itself. The way we move the variables to the other side to isolate P is either addition, subtraction, multiplication, or division. We can choose which one to do based upon how they are reacting with P. R and T are being multiplied to P, We're going to do the opposite, the inverse, which is divide. Dividing both sides by RT isolates P. And on the other side, you can leave your answer as I divided by RT. Let's do a little more complicated literal equation. X plus y divided by z equals 5. And put a number in there. I want to solve for y. I want to get y by itself. I'm going to erase y and make it a different color. No, I'm solving for it. The first step in getting y by itself, some people would think to subtract x. That is not the case. When we have a long fraction bar like this, we are going to get rid of the denominator of z. Z is being divided here to y. So we're going to do the opposite and multiply both sides by z. Doing that cancels out the z's on the left. So we're left with x plus y equals 5 times z can be left as 5z. The last step to get y by itself is to subtract x, subtraction property of equality. 5z minus x could be just left as 5z minus x. Nothing to combine there. And you are done. It's very difficult to check your work for literal equations. Just make sure you follow the correct steps. I'm going to write one more on the board here. I'm not going to solve it, but I'm going to ask you to try it on your paper, and I'm going to ask to see if anyone next time has the answer to this literal equation. Let's do it. Let's do AB minus BC equals D. And what I want you to solve for, I want you to solve for B. So that means get B by itself. Think about how we would do something like this where there's multiple B's in this literal equation. This is a little challenge question, but I know you can do it. Let's see what you come up with next time. Have a great night.